Hello and welcome back to Calculus 2 section 6.6 on surface area. That's the revolution again. We are going to rotate on x-axis, rotate on y-axis. This time we are not looking for the volume of the object. We are looking for the surface area of the object. So here is the object. That is the candidate. This spray bottle is a cylinder plus whatever this part over here is. And as you can see, has a circle as a cross section, which means you can obtain this by rotating. Now, your sections 6.3 and 6.4, disk and shell method, we're computing the volume, meaning how much of this juice you can fit in the spray bottle. What we are computing now in 6.6 is the surface area on which you get to paint, or the surface area on which you get to put a label or a sticker. You have to give, as engineer, dimensions of this area to a design team that will design this wonderful label that will make your product stand out for sale, right? So they need to know how big is the area they're working with to design, to put the company logo and those directions on how to use stuff inside and all of the things that are required. So we are computing the volume to know how much stuff we get to fit inside, but now with 6.6 we're computing a surface area to calculate, to compute surface area to, let's say, give those dimensions to designers to come up with some nice label and outside of the box. So what are we talking about? We are talking about rotation. So we are going to have some kind of a function, rotate that on the x-axis. On the other end, it comes out on the other side to be the same. There we go. Since you rotated this, it will create something like this. And we are talking about area on the surface. Of the object. We can clearly rotate on x or y, so we'll have two different set of formulas. You will use what you have to. So for the area, if you remember, area is two-dimensional, right? So observe the way I get this. Just look at the screen and then you'll catch up. It's like two seconds to write it. Do we all agree that integral a to b are the square root of 1 plus f prime squared of x dx is computing length of the curve? That will be the length of that black line. This is your f of x on top, right? So length of f of x between a and b. Do we all agree? That was the last lecture. That were the problems that we just practiced, right? So this is one dimension, right? It's one dimension. So what do I need for the area? I need one more dimension. So here we go. F of x, 2 pi for rotation, right? And we call that surface area S. Done. So you will augment your length of curve formula to compute the area of the surface revolution. So I hope you all see between this integral here and the square root dx that is your length of curve. We are only adding f of x in here and 2 pi outside for rotation, and we're good to go with surface area. We are going to write one more of these for dy, S equals 2 pi integral c to d f of y square root of 1 plus f prime squared of y dy, which is okay, that, and now I have to box that one as well. So that's our, now the one on the top is rotation on x, the one on the bottom is rotation on y. And that's it. Now, since I'm the best, we'll do the example as well. Because that's it. That's all it is. I'll pick something. What was that?
Something you would put on the exam or something.
The problem that is on the exam. I don't know.
That's something you would put on the exam.
Any of these?
17.
17.
Oh, the
The one with E. Oh, nice.
Who put this kid, Joe?
Who put
You guys would like to sit in the front, be my guest. Also, if you'd like to suggest something before I do, I gave everyone ample time to suggest something.
You are behaving the same way like me when I walk into a party, right? Food is available. I let the civilians have their go first. And yes, and then the professional moves in and clears it out. So that's exactly what he did, right? Now, we will be able to do this problem in 2 steps in about 2 weeks. Right now, let's go and work our wrists and go and do this problem. So we have function f of x, which is y, given as 1/4 e to the 2x plus e to the negative 2x from negative 2 to 2. We still need the derivative, so we'll take the derivative. So f prime of x is, copy 1/4, is a constant. The derivative would be 2e to the 2x minus 2e to the 2x. Negative 2x on top, yes, thank you. We will factor the 2 in the parenthesis, which will cancel with the quarter, for us to get 1/2 e to the 2x minus e to the negative 2x. Guys who are going to differential equations, pay attention, all right? These are your hyperbolic functions. So if you are going to differential equations eventually, this will be the other half of your solutions. You'll have your waves, trig, and you'll have these guys. Well, that's it. Let's go. Surface area. 2 pi. All right. We start with 2 pi. The negative 2 to 2 on the limits. We need to plug in the function first. So that's 1/4 e to the 2x plus e to the negative 2x. That's f of x. And now times the square root of 1 plus. And now we have 1/2. Let's write it this way, I guess, because we have to square it, right? Oh, I forgot to say that this is x rotation. That's important as well. Oops. So we have e to the 2x minus e to the negative 2x over 2. There we go. Beautiful. Look at that. So all we need to do is to integrate this, and we're done. You know what the beautiful thing about this integral is? It has e's all over the place. So it should be easy automatically, right? 2 pi integral negative 2 to 2. You know what is 2? It's going to be pi over 2 in front, because the quarter gets kicked out. So now you have your e to the 2x plus e to the negative 2x. And now we work out the stuff inside. So what do we have? We have 1 plus, this is e to the 2x over 2. So that's going to be e to the 4x over 4. Are we all green on that? E to the 2x times itself is e to the 4x, and then you have a half on the bottom, so 2 times 2 is 4. Minus. Now we multiply these. When I multiply these, each one has its own half. So we get e to the 2x times e to the negative 2x, that's e to the 0, that's 1. So we get negative 1/4 times 2, negative 1/2. You all see where is this going, right? And then plus e to the 4x. No.
Is it just very convenient that that keeps happening?
Yeah, it is. Otherwise we would be doomed. With 4 O's when you spell doom.
That's a lot of doom.
I know. Welcome to Calculus2. Plus e to the negative 2x. And now we have this 1/2 situation. So now we have e to the 4x divided by 4 plus 1/2 when you add 1 plus e to the negative 4x over 4 dx. Pi over 2, integral negative 2 to 2, e to the 2x plus e to the negative 2x. And now we compress this into e to the 2x plus e to the negative 2x over 2, everything squared, dx. This is where the square root and the square die, and we have pi over 2 integral negative 2 to 2 of e 2x plus e negative 2x with the square root of, no, square root is gone, I lied, of e to the 2x plus e to the negative 2x divided by 2 dx. The 2, 1/2, right, goes outside, making this pi over 4. Integral negative 2 to 2. And this is just squared, right? It's the same. Same binomials. So just FOIL. We have e to the 4x for the when you multiply. Then you have 2 times when you multiply them across. So that's going to be plus 2. Because e to the 2x times e to the negative 2x is e to the 1. Sorry, is e to the 0, which is 1. And then times 2 for the 2ab, for the middle term. And we have plus e to the negative 4x. In the end, all of that dx. So now we integrate. Pi over 4 in front. E to the 4x is going to be, now we're integrating, which means e to the 4x divided by 4 plus 2x plus e to the negative 4x over negative 4, computed from negative 2 to 2. Now comes the hard part, right? So we have e to the 8 over 4 plus 4 minus e to the negative 8 over 4 minus e to the negative 8 over 4 minus, and the minus gives us plus 4, and then when we plug in negative, that's e to the 8 over 4. We have a minus from the formula and minus from here. That's a plus, right? So it's a negative from here, negative from the formula. Yeah, it's a plus. Good. There we go. Nice. So we have pi over 4. Now I have e to the 8, that's 2e to the 8, so it's e to the 8 over 2, plus 8, plus, no, minus, I lied, e to the negative 8 over 2. And that will be it, right?
Okay.
We can multiply by a quarter. If you want to push the quarter inside, you can. So you will get pi e to the 8 over 8 plus 2 minus e to the negative 8 over 8. Yeah, we don't get to simplify this in a better form now. About chapter 7 is coming up, so we'll have our trusty hyperbolic sign for this situation, and the whole calculation is going to be 2 lines. But that's for that time. Perfect. These type of problems are excellent for killing time and carpal tunnels. You know, multiple purposes for problems like this. You know, so it's just
To exercise your hand.
yes. Yeah. If you don't have carpal tunnel by the end of the Calc 2 class, you'll definitely have. I mean, if you are passing the course. If you're not passing the course, obviously. You're not doing the work. So that's what it is. Calculation, as you can see, is the same as the previous. We still had the trick with the half, going back and forth and compressing it back, canceling that square root that it's a problem. You might run into other problems. Let's do another one, but this one is going to be quicker because I'm hoping to run into either a U sub or basic use of algebra to solve rather than having this lengthy trick of adding and subtracting half. So let's try problem number 9 might be good. The function is y equals 8 square root of x. We have 9 to 20 interval, and we are rotating on x-axis. You want to try this one on your own first? Of course you do, because you all love calculus so much. Hey, you want to be 1%? There you go. You gotta do another pattern. Course like for Thursday, 3 hours, right? We can stay extra.
Sure.
Saturday class, 5 hours.
Oh my God.
I had a question about oh, oh, okay. So then so when you're looking around the line, it's not axis. You have to factor it in. So in this is also working out as shell. That's why I said you take that's one you study. Function of step. That's the stuff you know, the stuff that I write.
I never so doesn't help.
So we're going to talk about so you know it.
Okay. So you Google sheet. Okay. Do that. All right.
So after you see potential cases, moving out the goal, they all ran off. More of the overarching goal of the potential Yes, that's good. That's good. So, it's fine. I have to someone. But then when you get it like cramp here, it doesn't sit well.
I knew it for the next 2 years.
It evaporated. Well, musical was coming forward. Oh, yeah. That's a start. Let me see if I can do the weekends.
Oh, yeah. Focus on the bottom. So that's still fine. Oh, we're going.
Student.
How do you decide which one to take?
If it's needed, you use your sub. If it's a basic integral, it's basic integral. Let's see what we have. The first order of business is to find the derivative, f prime of x, which would be 8. And then you have 1 over 2 root x, if you memorized it, I don't know. So that's going to be 4 over root x, which is good. So now, yes, I will be squaring it, so. So now, I have surface area of revolution, which starts with 2 pi. This is where your grade dies, with the 2 pi. Raise your hand if you forgot 2 pi in this problem. No one will self-identify, right? But I see your smiles, okay? I know what you're thinking. They give you away. So 9 to 20. And now we have our function, which is 8 root x. And then we have a square root of 1 plus, and now I have 4 over root x squared, and I have dx. We are using the dx formula because we are rotating around x-axis. Now we clean up this little bit. 8 goes outside, becomes 16 pi. I do have this integral 9 to 20. I still have a square root of x here, and I have a square root of 1 plus, and this over here becomes 16 over x. And then we have dx. And now here's the $1,000,000 trick. It's called elementary algebra. The square root of a times the square root of b is simply square root of ab. So we're just going to combine 2 square roots under the same square root, which means this x distributes simply and cancels the denominator one. So we have 16 pi. See, I don't doubt your ability to solve any of the calculus 2 algebra, however. However, so we have x times 1 is x, and x will cancel, so this works out to be x plus 16 dx. And this is a basic u sub problem, where we are using u equals x plus 16, du equals dx. u1, lower limit, plug in a 9, we get 25, and then u2, plug in 20, we get 36. So we have 16 pi integral 25 to 36 of square root of u du. We do not have to go back to x because we switched the limits as well. So we just compute this and we are done. It becomes u to 3/2 divided by 3/2. Plug in the limits. They work nice with halves, and we're done. So 16 pi u to the 3/2 divided by 3/2. I put the 2 immediately up to save on ink because, you know. 2 times 16, that's 32 pi over 3. And now we have our u to 3/2 computed from 25 to 36. I just wanted to simplify that real quick. 32 pi over 3. 36 raised to the 3/2 minus 25 raised to the 3/2 in parentheses. 32 pi over 3. Square root of 36 is 6. So we have 6 cubed minus, and then we have 5 cubed. Done. Now, what's 6 cubed? 216. And then what's 5 cubed?
125.
125. Good. So 32 pi over 3, which we have 216 minus 125. Next. Okay, so we have 32 pi over 3, and this number over here, that's 1, and then 21, that's a 9. That's not divisible. Equals a lot. Right, done.
No, it's not 90. It's a 91. Oh, yeah.
Yeah,
Okay, gotcha.
2,912 over 3.
Oh, yeah, well, no.
Pi.
Just figured it out.
Times, yeah.
I'll leave it with the 5.
Yeah, yes.
But if we put that on a test a lot, would you mark that correct?
Yeah,
You would?
yeah.
Okay.
I have to because it's fun. Come on, I gave points people for drawing the cat.
As long as we have all the other work correct.
Where did you get that 36 and 25 from? You had
When I did the use sub, you see in blue when I did, or maybe you can't see in blue from there, but
No, I can.
oh, good. So when I change these limits, you plug in the 9. 9 plus 16 is 25 for the lower limit, and 20 plus 16 the upper limit. Because I'm changing all x's, I better change x limits into u limits now
Okay.
by plugging in the formula that connects x and u domain.
It's because we got small, so I'm guessing. I'm just saying that's why we get a little confused.
Such is life, right?
I know.
All right, that's it. Bye.